I find it deeply fascinating how the development of mathematics, in particular algorithms, has touched almost every facet of human innovation. As we enter this new era of AI, new developments and discoveries of this technology are being made over very short time periods. Early disease detection lies as one of the most promising yet potentially dangerous applications of this technology. Algorithms can objectively and meticulously piece together pieces of information that is often missed by doctors. Over recent years, the medical industry has leveraged this in brain scans, X-ray, CT scans, and MRI to identify early stage disease and prevent misdiagnosis. By training these algorithms on large and vast amounts of labeled medical data, AI systems are able to pick up patterns, intricacies, and anomalies that can elude even the most experienced healthcare professionals. The added medical precision that we gain from artificial intelligence is revolutionizing the healthcare industry. In radiology, algorithms shift through thousands of images to detect minute changes that can indicate the development of cancer. In genomics, new genetic markers are being discovered that can give us insights into hereditary conditions. The research and application of machine learning algorithms on electronic healthcare records has provided clinicians with new tools to prevent and diagnose diseases. However, as the saying goes, with great power comes great responsibility. Several ethical and practical challenges emerge as we bring this technology to the forefront of combating disease. Systems need to be in place that protect patient data and value individual privacy. Not exposing algorithms to diverse datasets can result in biases and even misdiagnosis. We simply can't afford to hand it all over to the algorithms without human monitoring. As AI is able to discover new patterns and match these patterns to cancers, humans can learn alongside. It is important that we keep track of the knowledge that we gain from AI, not to undermine human value and innovation. AI is making significant strides in detecting various cancers such as breast, skin, and lung cancer. Let us go over some notable examples. Researchers at Google DeepMind developed an AI algorithm that's able to outperform radiologists in detecting breast cancer. 6 radiologists took part in an independent study where the AI outperformed all of the human readers. The AUC score, which is a metric to evaluate how well an algorithm is able to predict a particular outcome, for the AI system was greater than the AUC score for the radiologists by an absolute margin of 11.5%. The AI system can act as a second opinion for radiologists, and can be especially useful in cases of disagreement between the AI and the radiologist. In such situations, it can encourage radiologists to take further looks into X-rays or mammograms, and even aid in their medical knowledge for detecting breast cancer. An AI system was developed by researchers at Stanford University for detecting skin cancer, and it was discovered that this AI system was on par with experts in the field. The researchers suggested a really interesting idea that the AI system can actually be adopted in smartphones, so that people can detect skin cancer remotely. And I think this is a very innovative technology and can also be used for many other diseases. This can help reduce operational costs for hospitals and also enable patients to detect cancer at an earlier, more treatable stage. Researchers in France have been using AI systems to predict heart disease, in particular sudden cardiac death. They developed an AI algorithm that was able to provide risk profiles for different patients and identify which factors would increase or decrease a person's risk of sudden cardiac death within a given time frame. It was discovered that risk factors for different participants came from a wide range of medical fields, where neurological, psychiatric, metabolic, and cardiovascular data, which could all contribute to the risk of sudden cardiac death for a particular patient. Such algorithms are able to provide a holistic view of risk factors without requiring input of specialists from different fields. The research is there. AI can perform just as well, if not exceed, human doctors in detecting disease. It is now just a matter of scalability. What we need is the infrastructure to facilitate this technology. Global healthcare data centers that provide a centralized storage system for healthcare data where algorithms can train on and feedback results to centers across the world. In general, the more data the better, especially in a healthcare context. It prepares algorithms for certain caveats or rare cases, and diverse datasets can help reduce model bias. A common question I usually get is, if AI can outperform radiologists in detecting disease, why not replace radiologists with AI. This goes back to a previous point that I mentioned, and I think AI and humans should be learning side by side. AI can reveal patterns that we might not expect, relationships between CT scans and diseases that we might not be aware of. It's important that we keep track of this knowledge and that radiologists are able to learn from AI so that they can contribute to the development of better AI systems. When constructing an AI system, it is important that we have domain knowledge. If we simply remove radiologists from the equation, there are no people tracking the algorithms. We need this knowledge to be tracked and for humans to develop alongside AI. Thank you very much for watching, and I hope you found this video insightful.